So here they will be mostly focusing on your approach and how you are solving the code step by step. And we need to definitely explain the dry run by taking any kind of test cases. Hey Kodos, what's up? Hope you are doing great. Thank you so much for amazing response for the part 1 video, interview experience of senior AI engineer at EPAM. So most of you have commented for the part 2 video. So here is the part 2 video that we're gonna discuss about technical round 2, which is focused on hands-on coding, MLOps concepts, cloud architecture and system design. This round was less about theory and more about whether you can actually build and deploy production-ready AI applications. So topics we're gonna cover in this video are FastAPI, Pydantic and Retry logic, MLflow, fine-tuning and AKS versus serverless, and more of coding questions. So I have added the major coding questions that they have asked in this technical round at the end of this video. So do watch the video till the end. Before getting started, do like, share and subscribe to my channel. Let's go. So starting with the FastAPI development and production. So the interview started with a hands-on backend discussion around FastAPI and production grade API development. The first question was, how do you validate incoming requests in FastAPI? Mostly we can explain about Pydantic BaseModels for request validation and schema management. And FastAPI is automatically validates the incoming data and returns validation errors when needed. And next question goes like, how would you implement a retry logic? So the good answer can be using the exponential backoff and define a maximum retry count. This helps when external APIs and LLM services temporarily fail. Next question is about error handling. How you will be exactly handling the errors? Using the custom exception handlings and centralized logging, so failures become easier to debug and monitor. So the interviewer also discussed the typical API architecture. Here you can refer to the client validation, FastAPI, logic and response. How the entire flow works, we can explain clearly. So the incoming request progress sequentially through decoupled validation and business layers. So I can say the key takeaways from this section was, building APIs is easy, building a scalable and fault tolerant APIs is what senior engineers are expected to do. So the next concept goes like, what is MLflow, fine tuning, LoRA and PEFT, parameter efficient customization and experiment tracking pipelines. So machine learning flow is primarily used for experiment tracking, metrics comparison and model versioning. So they have also asked about model fine tuning. Like fine tuning means taking a pre-trained model and adapting it to a domain specific data. We can explain with example, like a general purpose model can be fine tuned for healthcare, finance or customer support use cases. So they have also asked about LoRA. LoRA stands for low rank adaptation. Instead of updating billions of model parameters, LoRA updates only a small subset. This significantly reduces the GPU cost and training time. And they have also asked about PEFT. It stands for parameter efficient fine tuning. So here the goal is to achieve good model performance while updating only a small portion of parameters. So we have also discussed about entire model optimization pipeline like base model, fine tuning, thereafter LoRA and optimized model. This continuous optimization loop reduces deployment overhead and parameter footprint to get the accurate results after fine tuning. So here comes to AI deployment architecture like serverless versus AKS, choosing the right infrastructure for AI workloads. So interviewer was asked about difference between the serverless and AKS Kubernetes, which deployment process we will be using for the AI application deployment. So we can explain the complete difference. Like for serverless, it is auto scaling and pay per use and event driven workloads. For AKS, long running services and multi-container applications and enterprise scale deployments. So AKS is preferred for long running AI services and multi-container apps and enterprise scale. So here you can see the entire architecture flow topology: users, API gateway, FastAPI and AI models, DB monitor. So users will trigger the request. The request will go to the API gateway. Thereafter, a FastAPI layer is used to get the optimized response, and the response is given to the AI model. Thereafter, we will be using that in the DB and monitor section. So the mainly deployment choices depend on workload patterns and required control. Next goes with the coding questions that they have asked. This interview went almost around one and a half hour. There we have discussed about the coding concepts for almost 45 minutes. So here are the coding questions that they have asked in this EPAM interview for AI engineer role. The first question goes like first non-repeating character. So here we need to explain the approach first. Thereafter we need to explain the brute force approach and the time and space complexity that we are getting in the brute force. Thereafter we need to optimize the solution further. It's an optional, but it's better to give an optimized solution to explain the solution in a better way. So the approach we can follow for this question are using the frequency counting, and the complexities goes like O of n for time and space complexity. You can also refer to any type of questions where we can solve in O of log n time complexity, which is most optimized. And the next question goes like a missing number in array. Compare the expected sum to actual sum. So we can directly find the missing number in the array. You can also check the implementation logic like a first unique string, thereafter a missing number in the array. So here they will be mostly focusing on your approach and how you are solving the code step by step. And we need to definitely explain the dry run by taking any kind of test cases. So this is what companies are hiring for 20 to 30 LPA AI engineer roles. If you enjoyed this part 2 interview experience, make sure to like the video, share it with your friends and subscribe to Being Pro Coder. Also let me know in the comments. So thank you so much for watching the video till the end. See you in the next video. Bye.